folks, my name is Bill and I'm a developer advocate here at Rerun. We're on part 5 of the Gentle Introduction series. We've done the basics, we've moved into working with some real world data, and now we're going to get into some really fun stuff, which is showing you how you can query data out of Rerun and really use it in, full featured data pipelines. And so this section or part 5 here is really going to focus and dive into that. Now, I will say that you must have run the code in part 4 and you need that same data file because what we're going to do is we are going to run through a Jupyter notebook. We're going to query data out of there and we're going to play around so we can better understand the querying capabilities in Rerun. Let's go ahead and get started. All right, folks, so in order to do this, I've started up a couple of terminals and I'll just go ahead and close these so you can follow along. The first one is just running the Jupyter notebook that we are going to walk through. Let's make sure that that's big enough. Check. The next one is we are going to start up the Rerun server. Now, the Rerun server is going to allow us to point at a directory. So this is just the directory that we created last time. And that will start up a server, which I guess will become more obvious in a moment. From there, what I can do is I can actually run Rerun connect to that server. And let's go ahead and do that. What that is going to do is that is going to show me the file that I created, remember example timeline, and we can actually open up that particular recording as well. So here we have it. This is just the data from last time. So basically, rather than opening an individual RRD file or MCAP file, I'm able to open a folder of them. And those will show up as a series of recordings here. So I have this data. It's the same data that we discussed in the previous video. And in another process, I basically started up the viewer and said, hey, I want to connect to this particular server. So why is that powerful? Well, somewhat obviously, you could have multiple people connecting to a particular server. You're decoupling the viewer from that actual server or server process. So there's a lot that you can kind of do with it, right? Just having that dedicated client. And so now that we have this viewer up and running, let's talk about actually querying data. So I'm in this notebook and we're just going to walk through it. So I'm on actually like a little bit of a late version of Rerun. Well, I'm like a little one step behind basically, but no matter. So what I've done here is I've actually taken the same URL here, or URI, saying that I'm connecting to this local host here. And so, these parameters don't really matter. I do have this, hey, we want to serve this locally because we want to be able to view it well. And you'll see here that I'm going to go ahead and start up this catalog client pointed at this particular URL. From there, I am able to query data. So first things first, we can get, just as we're working through this, we will print out all the entries in here, which will show us all the basically data sets inside of here. And I'll grab the first one, which will be example timeline. We can see, boom, we have it as a data set. Now, what we can do here is we can get this data set or like all of these files in here as a table. And this allows us to understand, hey, when was it registered? Where is it stored? What's the type? That sort of thing. And the key here is that this is just kind of an entry point, a way of organizing things. And so this stuff, this part of the product is certainly under active development, but a lot of the core concepts are going to be very static over time. What I'm able to do is I'm able to get the schema of this particular file as well. So I'll kind of understand the exact columns in here. And from there, I can actually see the timelines as well. So the index columns. Remember, in the previous code for this IMU data, we had send columns with a particular index. And so we are able to somewhat obviously query those index columns out as well. We can also get the raw columns, which are all the component columns as well. That's what we'll see up here in the schema. Now, I kind of get tired. It's a little bit, sometimes it's a little bit wordy to type all of these particular things. So I just have a little function that allows me that given all of these column names, I can just move this down here so it's a little bit clearer. Given all of the column names, I can now look them up by keyword. And this just makes it so that, you know, you can say, hey, give me the GPS colors or whatever, and you'll be able to query for that. Now, here's where things get a little bit more interesting. Just like when we scrub through here and select, you know, a timeline like obstacle time, you'll see here that we just sort of have, you know, more or less the value that is latest at a given point in time. We're able to sort of simulate the same query that the viewer is making, except do it in code. So for instance, if we wanted to see this, here's obstacle time, right? If we wanted to see the exact obstacle time, excuse me, I need to do obstacle df. We can see it right here, and we can see that there are only 6 rows, which is exactly what's expected here, and that at each of these timestamps, we can see all of these values, like the IMU time and the GPS time, like the exact same values at this particular timestamp, right? And what that allows us to do, I guess, when these things are not well aligned, so in our example, right, they're perfectly aligned with the same timestamp, right, that we have right here. Here's our notions of time from the previous one. We're using that same current time. Now, if we were to, say, jitter these a little bit so that they were not on the exact same timestamp, then what we would need to do is we want to maybe grab like the latest value and pull it forward, right? And what we can do there is, I guess, reading through this, we have this data set which says, hey, give me this data according to a particular timeline, like obstacle time or GPS time, okay? And then the DF converts it into a DataFusion data frame. So DataFusion, Apache DataFusion, is a tool by which you can execute SQL or SQL-like queries. And so this gives us a ton of flexibility. We can convert it into DataFusion, we can convert it into Pandas, and we'll sort of talk about that in a little bit. But I think really what I wanted to point out here is this gives us a really flexible way of basically getting the latest values at a given point in time and pulling them forward. And so, you know, we can do that for, this is for like the IMU data, which I guess since it has the highest frequency, it might not be the best example, but we could do it for the obstacle data. This here. Yeah, okay, great. So there's for GPS data as we pulled that data forward. And, you know, by and large, what we're seeing here is that these update rates are different. And they're on the same timeline. The big powerful part of this part of Rerun, of the querying interface, is that we can just keep our data stored in a pretty optimal way where, you know, we're just logging these different timelines, and then we can align them to the proper timeline as well by basically grabbing that latest data. And I think that over time, Rerun will cover more and more ways of sort of interpolating values, maybe lagging several rows, that sort of thing. And this is an area that, as I mentioned, is under active development. And so, you know, here we have these IMU data frames. Yeah, so actually the IMU is probably the best example here. So let's go back to all of this. So here, if we look at the IMU data, right? Okay, great. At this point in time, the detected obstacles and GPS position is null, right? And we can actually see that in the data, right? We see it as GPS is null and the IMU is there. Sorry, I need to get to the obstacle detection. All those are null, right? Now, if we fill it with the latest value, we'll see that the GPS position is static here until we, boom, hit that new value, at which point the row is filled in with that. And we can see that also the same applies to the detected obstacles, right? And as I was just kind of calling that out as we're sort of exploring it, what we're able to do is query and say, hey, Rerun, give me the all of the data according to the IMU value but I want to pull forward or pull, the latest detected obstacle value that we have. And that gives us a ton of flexibility for things like machine learning, where you can prepare all of this data and prepare, rows of data to feed into, an AI model. So let's see here. I have shown that IMU data frame. I've shown here that we can also grab specific content. So for instance, maybe we just want to grab the drone, components entity, that we can do that way. Here you can see that maybe I want to like unnest a particular column. So, a lot of these values are stored in certain ways, often as lists, potentially even like lists of lists as well. And so what this allows us to do, this is really just a DataFusion capability to unnest columns, right? And with that, we can even grab the top 5 rows and then convert it into pandas as well. Some more example queries here. I think really what I'm just trying to hone is that this gives you a lot of flexibility. We can grab, hey, what's the number of obstacles at given points in time? So we add this column, we filter where the number of obstacles is greater than 1, and then we filter the drone position as well, and then we convert that into pandas, right? And so, it's a little nonsensical since this is synthetic data, but it allows us to have these clean, frankly, like query capabilities to kind of understand and be able to work with this data, right? So here we can see that, ignore the as column, that's just an artifact of my little helper function, but hey, I want to see the first value of the drone GPS positions here, right? And I could even convert those into a string, right? And I could say, hey, show me the distinct number of drone GPS positions in this data set as well. And so now you've seen how Rerun allows you not to just store and view data, but also be able to query it in turn. And as I mentioned at the beginning, there's an active area of development, and so we'd love to hear about your use cases. Please reach out on GitHub, reach out on the Discord, and look forward to seeing you there.